Hello everyone, welcome to TalentSprint. So in this session of chemistry, we shall discuss the chemical bonding topic. So moving on to chemical bonding topic. So what do you mean by a bond? Why it is called as chemical bond? So first, matter is made up of one or two or different types of elements. We already know it. So however, a group of atoms is found to exist together as one species having characteristic properties such as group of atoms called molecule. Suppose we have hydrogen atom and oxygen atom. They combine to form a molecule called water, that is hydrogen oxide. Okay, clear with this? So it is called water molecule, right? So for some characteristic properties they combine each other and it is called as molecule. The attractive force which holds various constituents of that atoms or ions etc. together in different chemical species is called as a chemical bond. So the force which is holding them together is called as a chemical bond. Clear with this? So then why do atoms combine and why only certain combinations are possible in this world, and why do molecules possess definite shapes? Okay, do you have the same questions in mind? So I do have the same questions in my mind, and what is a single answer? Do we have different answers or single answer? The only answer is, so they combine for stability. Okay, so stability is the whole answer for the chemical combination or chemical bonding. Every system tends to be more stable, and bonding is nature's way of lowering the energy of the system to attain stability. To attain stability, every atom will form different bonds, and only certain combinations are possible. If there is no stability requirement, there is no bond formation requirement. Okay, so and they have definite shapes. So atoms combine for the reason to attain stability. Okay, moving on to different concepts in chemical bonding. The first is valence electrons. You know about valence electron, the outermost electrons in the outermost orbitals which are free, and they are called as the valence electron. Then what is octet? Octet stands for 8, right? So atoms of different elements take part in chemical bonding and chemical reaction in order to complete their octet to reach the nearest noble gas configuration. So octet means if I want to reach the noble gas configuration, nearest noble gas configuration, that is called octet. Okay, suppose if I have hydrogen, so next nearest noble gas is helium, right? So hydrogen has atomic number 1 and helium has 2, so I need one more electron for this, like that. Okay, so clear with this? So octet rule means nearest noble gas configuration must be reached so that octet is completed and it attains stability. Next theory is related to chemical bonding. We have four theories. One is Kössel-Lewis approach, which was given in 1916. Next is valence shell electron pair theory, repulsion theory, VSEPR theory given in 1940. Valence bond VB theory 1927, molecular orbital MO theory given in 1932. So we shall see all these theories. The first is Kössel-Lewis approach. So Lewis pictured the atom in terms of a positively charged kernel, the nucleus plus the inner electrons, both protons, neutrons and electrons. He said it is called as kernel, and the outer shell that could accommodate maximum of 8 electrons, like we have a cube. So if I take a cube, we have the 8 corners, right? So at the 8 corners we have 8 electrons. So this was imagined by Lewis, okay, and he called it as kernel. He further assumed that these 8 electrons occupy the corners of a cube which surround the kernel. The octet of electrons represents a particularly stable electronic arrangement. So when these 8 electrons are reached, then the bond is completed as per the Kössel-Lewis approach. So Lewis postulated that atoms achieve the stable octet when they are linked by chemical bonds. So chemical bonds are taking place only to attain the stability and reach the octet, that is 8 electrons configuration. Next is to achieve stability, that is octet, the atoms may share or transfer. So two types of bond formation is taking place. So if it is sharing of electrons, it is called as covalent bond. If it is transfer of electrons, it is called as ionic or electrovalent bond. So first we shall see about covalent bond. So covalent bond means it involves the sharing of electrons. Suppose if we take chlorine, it has atomic number 17. So one it has one electron is needed, that is nearest noble gas is argon, that is 18. So it needs one electron. So if I take two chlorine atoms, so if I share one electron with each other, that will form a single covalent bond, right? So what do you mean by double covalent bond? If two electrons are shared, that is called double covalent bond. If three electrons are shared, that is called as triple covalent bond. Hope you are clear with this. So covalent bond means sharing of electrons takes place. And next, ionic or electrovalent bond we will see. Before that, we shall see the different Lewis representations. So if there is one bond, it is called as one line. If there are two bonds, two lines. If there are three bonds, it will be three lines, obviously. Clear with this? So moving on to types of covalent bonds. And what is sigma bond? So sigma bond means which is formed by the head-on overlapping of two atomic orbitals. So what do you mean by head-on overlapping? So it is called as edge overlapping. Okay, so edge overlapping is called as the sigma bond overlapping, and it may be SS orbitals or SP orbitals or PP orbitals. Hope you can see here SS, SP, SPP, like that. Okay, this is called edge overlapping. Okay, if I take side by side overlapping, it is called as pi band overlapping, which is formed by the side to side overlapping of atomic orbitals. It may be PP and PP. Only PP overlapping is possible. We can't have SP overlapping for a pi bond. Okay, pi bond is not possible for SP. Okay, only for PP overlapping. And if there is a single bond existing between two atoms, the bond will be sigma bond. If there are two bonds, always remember there will be one sigma bond and n number of pi bonds. So first will be sigma and then will be pi bond. If there are three bonds, first will be sigma, then next will be pi bonds again. Okay, moving on to the ionic or electrovalent bond. We have already seen ionic or electrovalent bond means it involves transfer of electrons in the valence shell. Okay, one has extra means another has deficiency means it will transfer, the surplus will transfer to the deficient. Okay, Na plus Cl minus, right? So sodium has one extra electron, it may be given to the chlorine, which is atomic number 17. They reach the nearest noble gas configuration. The sodium will reach the neon, that is atomic number 10, and argon will be reached by chlorine. Okay, the transfer of electrons will be taking place. Like that we have for the same. Okay, so Na plus Cl minus, so that they will transfer the electrons from the surplus to the deficient ones. Moving on to the next theory, the second one after Kössel-Lewis approach. The second is valence shell electron pair repulsion theory, VSEPR theory. So it says the Lewis concept explains only the bond formations, but it doesn't explain the shapes of molecules which are formed. So VSEPR theory explains how the shapes are formed, or different shapes associated with the bond formations. Okay, so it says if there are single bonds, it is linear pair. If there are three bonds, it is trigonal planar. If there are four bonds, it is tetrahedral. 5 means diagonal bipyramidal, and 8 means octahedral. Like that, different number of bonds will have different shapes. Okay, this is explained by valence shell electron pair repulsion theory. So hope you are clearing with the part 1 of the chemical bonding topic. We shall meet in the next sessions. Thank you so much.